Hello guys, my name is Layla Gold and I am going to be teaching you guys about the chain rule. Today is September 29th of 2025. So first things first, to get started, when we're talking about the chain rule, we're generally going to be looking for three different things to know if we can use it or if it's applicable. So the first thing you need to look at is, look at the function. Is the function a composition function? Okay, well, what is a composition function? Well, the most basic composition function you see is h of x equals f of g of x. Does it ring a bell? Okay, let's put some numbers in it now. So another composition function you can see is h of x equals cos of x to the power of 3. So a composition function usually has a very clear inside function, which would be x to the 3 here, and a very clear outside function. Okay, cool. Now that we have number 1 out of the way, we have that checked off. Next, you check, is the inside derivable? Okay, well in this case scenario, we have x thirds, which is derivable. Well, the derivative of x thirds is 3x squared. So we know that's derivable. So now that we've that checked off, we can go look at the outside function. Is the outside function derivable at that point of the inside function? Okay, well our outside function is cos of x, so can we derive cos of x? Well, by trig derivative rules we can. So the derivative of cos of x is negative sine of x. So the outside function, the inside function are derivable, and it's a composition. If all three of these apply, you know you can use the chain rule. Okay, so we have our first example here. It's going to be a polynomial and power rule, and is h of x equals 3x plus 2 to the power of 4. So we need to first identify this as a composition. Well, we said there's a power, so we know that there must be a composition because there is a power. Okay, what is our outside function? Okay, so if we're plugging in 3x plus 2 into something to the power of 4, and x would be our most common variable, we know that our outside function is most likely f of x equals x to the power of 4. Now, let's find a derivative of our outside function, make sure it's differentiable, and it looks like it is. 4x to the power of 3. We pull our 4 to the front because of the power rule, and we subtract 1 from that exponent, which would give us our now derivative. Okay, let's look at our inside function. So our inside function we know is g of x, which equals 3x plus 2. If you're confused why I'm using f of x and g of x, that's because we know that f to the g of x is equal to h of x, which is just our common formatting. Okay, so back to it. We have g of x is equal to 3x plus 2. We need to find the derivative of that, which we know 2 is a constant, so it's 0, and 3x is just 3, so 3 plus 0 equals 3. So now we know that our inside and outside functions have a derivative. We can find the derivative of the entire function using the chain rule. So we have h prime of x is equal to, let's derive the outside first. So we have power rule 4 times 3x plus 2. And then that's going to be multiplied by the derivative of our inside function, which we know is just 3. So here is our final product for the derivative using the power rule in a polynomial. Okay, so here we are with another example. Okay, so there we go. So we see that in this example, it is a trig and polynomial function. Okay, well, we're going to do the same process. We can see that this is clearly a composition function because there is a clear f of x, outer function, which is going to be sine of x, and we know that the derivative of sine of x is cos x. Okay, and then there's also a clear inner function, which is g of x, and that is going to be x squared, and the derivative of that inner function is going to be 2x. Okay, so now that we know there's a clear outer function, f of x, and inner function, g of x, we know that h of x is able to be derived. Okay, so we are going to now derive the whole function together using the chain rule. Okay, so first we'll derive the outside function, so we will have cos, and then its composition, so x squared, and then that will be multiplied by the derivative of x squared, which we found out is 2 of x. And there we have it. This is going to be our safe stop. Okay, so now we have our third example. This is going to be an exponential and linear. So we see here, that's definitely composition. Again, we have an outer function and an inner function that are very clear. Okay, so first thing we are going to do is identify the outer function. So we have f of x is equal to, our outer function here is e to the x. And what is the derivative of e to x? Well, we know that derivative of e to x is just e to the x. No change. Okay. So now that we have our outer function, let's derive our inner function. Okay, so our inner function can be determined by g of x, which is 5x minus 1. And what is the derivative of g to the x? Okay, well, 1 is a constant, and derivative of 5x is 5, so it's 5 minus 0, which is just 5. Okay, so now, by using the chain rule, we can derive the entire thing. So h prime of x is equal to outer e to the 5x minus 1 times the derivative of the inner, which is just 5. So we really just have 5e to the power of 5x minus 1. And there you have it. Okay, so here we are with another example. This example is going to be square root of a polynomial example, so we're getting a bit more advanced. So I'm going to rewrite this function as h of x is equal to root 4x squared plus 7, just so it's a little clear. Okay. So we need to identify an outside and an inside function. With a root function, our outside function is technically, this whole thing can be written as 4x squared plus 7 to the power of 1/2, right? But there's also a few ways we can go about it, and I'm going to go about a little bit of a different way than this, so it's easier to simplify. So if our outside function in this case is root x, see, if we have root x, then our inside function is 4x squared plus 7, then we'll just plug into the x. Then we know a derivative, because we memorized it, of f prime of x is equal to 1 over 2 root x, then we can just use this to our advantage. So we know the derivative of our outside function, and now we can take the derivative of our inside function. G of x is equal to 4x squared plus 7, and g prime of x is equal to, well, we have the power rule, so 8x is 7 is a constant, so we know that there's nothing we can really do about that. So now if we're to derive the entire thing, we have h prime of x is equal to 1 over 2 root 4x squared plus 7 times 8x, and if we simplify this, we just multiply the top by 8x, and then we would just get a final product of 4x over root 4x squared plus 7 Run out of room. Okay, and that's just because we have 8x on top, 2 on the bottom, and so we know we can divide 8 by 2, which would just be 4. So this would be our simplified version. This is our safe stop version, and both work perfectly fine. Okay, and we're back with our final example. So this one is a bit more advanced because it is a 3-way chain rule. So let's rewrite our function. Okay, so we have h of x is equal to e to the power of cos x to the power of 3. Okay, so what we're first to think of is, okay, well, what's our battle plan here? Okay, so we need to see what is our outer, inner, and inner function. Well, we know that our outer function here is going to be e of x. Okay, so that's our number 1. Now what's next? Well, then we have cos, and then we have x thirds. Okay, so we're going to have, let's call it, let's have, I don't want to be confusing. Let's say that, okay, let's say function e of x equals e to the power of x, which is our outer, and we have e derivative of x. Well, what's the derivative of e of x? It's e of x. Okay. Then we need to determine what is f of x, which is going to be our middle function in this case. And we know that f of x is cos of x in this case, and the derivative of cos of x is negative sine x. Okay? And now, lastly, we need to find out our outer, or very inner function, which is going to be g of x. And we know that x thirds, the derivative of that would be, because of power rule, 3x squared. So now we know all of these factors. So now we just need to write it in a chain rule formatting. So we have h derivative of x is equal to e cos x thirds times negative sine, because our middle function there, x thirds, finally times 3x squared, the derivative of that inner function. So this is our final derivative. So we have e to the cos x thirds times negative sine x thirds times 3x squared. So it's really just about finding what order do I derive them in, what makes the most sense. Okay, I just want to say thank you so much for watching. Just for a little recap, today we talked about the chain rule. We did 5 examples, all with different types of functions, like polynomial, exponential, and we used the power rule. We used many different rules that we're going to use every day while deriving a function. If you're still confused on how to use the chain rule, you can always go and look back at one of the examples. The examples went in order from easiest to most difficult. Thank you so much for watching.